Um, hi everyone, happy to be here. Also, special thanks to the organizers for having a bit of philosophy in the program. I appreciate that. So we're going to talk today about Peirce's philosophy of mathematics. And Peirce was a scientist, logician, philosopher from over a century ago. And his work recently inspired advances in categorical logic, which is something I'll mention in a few minutes. But what brought Matt and David and I together is that we asked what else might we take from Peirce's work. And so this is going to be a talk about some of these future directions. That'll include further work on the graphs, Peirce's notion of scientific inquiry, and then his more general theory of semiotics. So this is going to serve as an outline for the talk. There'll be a preliminary. I'll spend maybe the first 5 minutes giving an overview of Peirce's philosophy, and that'll serve as a segue into the remaining 3 sections of the talk. So I'm gonna give an overview of Peirce's philosophy by using some choice quotations. These come from most of them are adapted from passages from Donald Mertz, but he writes of Peirce. He says this. He goes, "It becomes possible to conceive of an object not only in terms of inerring qualities, but also in terms of relations among its states and with other objects. From this, it is possible to think of an object in terms of its behavior, where the essence of an object lies in the sum total of all the relations into which it enters with other objects from one-term relations on up. Peirce observes that behavior and relations can then be equated. From this, it follows that the meaning of the concept of an object can be given by the set of laws that completely specify the behavior of the object under all conditions." Peirce's pragmatic maxim is then the following: "Consider what effects that might conceivably have practical bearings we conceive the object of our conception to have." So these are the behaviors, the potential behaviors. "Then our conception of these effects is the whole of our conception of the object." And this maxim is what leads Peirce to develop maybe what he's most well known for is his philosophy of pragmatism. Moving now from this connection between relations and behavior to scientific practice, Mertz writes, "Our knowledge of concepts is then always relational and partial. The best one can hope for is the self-corrective nature of thought proceeding according to the scientific method. This method proceeds by forming an explanatory hypothesis." That is what Peirce is going to call abduction later on in the talk. "Deducing consequences from that hypothesis, and then testing through induction whether and to what extent those consequences are found when expected in experience." So Peirce was convinced that all cognition, whatever, was therefore inferential as opposed to immediate and intuitional. So now we have this relations first worldview that leads to, or that connects with scientific practice, and then a type of inferentialism. Moving to mathematics, Peirce writes of the practice. He says the hypothesis of the mathematician is always the conception of a system of relations. In order that they may be reasoned about mathematically, these relations must be conceived as embodied in some kind of objects. But the character of the objects, apart from the relations, is utterly immaterial. They are always made as bare, skeleton-like, or diagrammatic as possible. The mathematician often passes from one mode of embodiment to another. Such a change is no change in the hypothesis, but only in the diagrammatic embodiment of the hypothesis. The hypothesis itself consists in the system of relations alone. Now, Peirce at this time, so he has this notion of relational and diagrammatic mathematics, but I think his motivation for this is actually quite modern. So he was working with the time with his father on a somewhat, I think, significant paper in the history of mathematics. It's where it's the first use of idempotent and nilpotent, for example, and this is this linear associative algebra paper. And Peirce realized at the time that there was this analogy between relations and linear algebra, and his developments in logic actually developed that connection too. And then he was trying to come up with a graphical syntax to better express these relations, and that led to his development of the existential graphs. With respect to the graphs, Peirce spent a great deal of time and energy studying and developing. This is by 1903, they say. Peirce probably started developing them in the 1880s. The value of a graph springs from its being veridically iconic. So that's a fancy name for saying it's naturally analogous to the thing represented and not to a creation of conventions. The value of the existential graphs lies exactly with the fact that they represent logical relations by such spatial relations that the necessary consequences of these logical relations are made evident by transforming the diagram in certain ways. The existential graphs, Peirce says, puts before us moving pictures of thought, which allow us to draw conclusions by a series of steps, each of the utmost possible simplicity. So to give a bit of a summary of these points, I think Peirce's larger philosophy is captured nicely by the Trinity. So this is the connection Peirce finds between logic, science, and semiotics. Peirce extends logic to go beyond just deduction, but to include abduction and induction, and that's likens it now to full scientific practice. As those opening passages suggested, Peirce thinks that all concepts are relational and behavioral. So there's this connection between semiotics and science. And then thought itself is mediated by science, and that leads to the type of inferentialism that Peirce goes on to adopt. So that's the first kind of broad overview of Peirce's notion of his philosophy and his mathematical practice. And then I'll move now to some of this more recent work on the graphs. So the existential graphs are a graphical calculus for the logic of relations. When Peirce introduced them, he defined a logical graph as a polar valental graph. So valental, he had in mind valency in chemistry, where you have chemical molecules that have open binding sites that you can join up, kind of compose and form larger molecules. So he saw relations as working this way. And then polar, because he thought that these were either positively or negative, either had positive or negative connections. So they were kind of asserted as holding together, or they were disjointed and say negated, or there was a difference between them. He also stated, I think this is kind of remarkable, he stated in natural language the rewrite rules for Cartesian bicategories. So he understood, he called these wires lines of identity. He talks about branching lines of identity. He gives, in natural language, he gives the intuitions behind the Frobenius equations. And his inference rules actually correspond in the positive fragment to these inequations here. He talks about breaking a wire. He talks about erasing a graph or a relation, and then splitting or copying a relation, so long as you keep the ingoing and outgoing wires the same. To those rules, he added rules for negation. And so this lets us go from the positive, the regular fragment of first order logic, to full first order logic. And he does that again with three, I think, kind of remarkable rules. One is the top left there is the principle of contraposition. The top right can be thought of as double negation elimination and introduction. And then that bottom one is, I think, a rule that's unique to Peirce, and he calls it iteration and de-iteration, which is that if you have a copy of the relation, you can move it inside the negation, so inside that cut, or pull one back outside. And those are sufficient for extending that fragment of first order logic. And then he also understood the algebraic significance of the graphs. So I think this is a passage that should maybe go down as one of the earliest, it's at least the earliest that I know of, instances of string diagrams as we know them today. So Peirce uses S here as sum or addition as the node, and then he writes the associativity of sum, the commutativity of sum, and this is the one on the right is the existence of negative quantities by having a type of feedback in sum. And if we look at this in the case of associativity here, this is exactly how we draw associativity today in string diagrams. So this is in 1903. So I said at the beginning that some of Peirce's work is now led to advances in contemporary categorical logic. This is an account, so if we start with, this can be found in this paper with Filippo, Diagrammatic Algebra, First Order Logic. We call it the Neo-Peircean Calculus of Relations. And you start with the axioms for Cartesian bicategories, this regular fragment. You add the dual to that. So you go from the regular fragment, the existential conjunctive fragment. Now you have a universal disjunctive fragment. Significantly, the relational composition now has a corresponding dual to relational composition that Peirce calls relative sum. And then these interact via rules for linear bicategories. And it turns out that all of these features were actually present in a novel version of the logic of relations Peirce gave in 1883. So he emphasizes the dual of relational composition. He emphasizes linear negation, linear distributivity, and so that's why it's taken. That's why we call it the Neo-Peircean calculus. Now, I think this is just an aside, but for future work, I think the closest kind of contemporary theory to this is Lambek's bilinear logic. So that's I'm just going to flag that for potential interesting future connections. And then now, as a bit of a segue to Matt and David's talk, this is a version of a graph that Peirce drew. So this is the way you read this. You start from the outside and you kind of work your way in. So this says there is an artist, and if that, so this shaded region is the antecedent of an implication. So there is an artist. If that artist looks at something, then that looking artist will see beauty in that very thing. So another way to phrase that, an artist sees beauty in all they look at. And the question that Matt and David and I were looking at was whether we can extend this graphs, this deductive calculus, beyond deduction to include something like abduction. Peirce suggests as much. He says that this shaded region here should be seen as a type of possibility, like a scientific hypothesis. And then are there broader semiotic lessons to draw from the graphs? So this Peirce thought that the graphs showed that we could have, for example, there's an artist here is a monadic relation, looks at and sees beauty in our dyadic. And he thought that the graphs showed that the composition of relation could always be broken down into monadic, dyadic, or triadic relations. And so he came up with this general theory of semiotics that had this firstness, secondness, and thirdness built into it. So we're going to we'll move to David here next to chat about the abduction and deduction and inductive side of this, and then we'll have Matt to chat about this general theory of semiotics.
Okay, great. Thanks a lot, Nathan. Yeah, I encountered Peirce a very long time ago. I think it's getting close to 40 years now. But I was fascinated with him in my 20s, and really gripped by the existential graphs in particular. So they cropped up a little bit in my 2003 book. I had a final chapter on higher dimensional algebra, very inspired by John Byers there. And they make a brief appearance there, but there's nothing very systematic. So I was thrilled to find later category theorists taking out Peirce, reaching a high point, I guess, in Nathan and colleagues' work. Okay, but something clearly noticeable about this is they're dealing with deductive logic. They're looking at they're looking typically to understand these graphs in terms of the role they play in deduction. And Peirce, if he's famous for one more thing in terms of inference, is to see inference as a triad, and deduction is one wing, one part of the triad, and coupled with these are induction and abduction. If we could have the next slide. Right. So abduction, I mean, induction, I guess, is familiar to most people. Abduction is perhaps the least familiar. It's very much to do with the pursuit of good explanatory hypotheses for phenomena. We may have some facts before us, and we're wondering, what's going on here? What explains why I see what I see? You could think of the detective, the whole bunch of well, there's a dead body in front of them, Agatha Christie novel, and they're trying to come up with the hypothesis that explains why they see what they see, and all the clues, that they can see. Okay, so if deduction, it gets taken up by the category theorists, where are the other two gonna appear? So I thought I had about 8 years ago now, and never really worked on it very hard, but it seemed to sort of fit quite nicely, was to think that if deduction sort of sits quite happily with the composition of morphisms, why not look at the other two in terms of extension and lift, other ways to complete triangles of morphisms. Okay, so if you could, next slide, please, Nathan. So deduction, that seems pretty reasonable. If I've got a map from A to B, if I've got if B follows from A and if C follows from B, it looks pretty clear that C follows from A just by composition of these morphisms as kinds of inference. Induction, well, a classic case is when I've got a population B, and I'm interested to know something about these the members of B. So I take a sample by finding a monomorphism, say from A to B. I take a sample of B, and then I find out the answer, the labels that are applicable to these elements in the sample by a map from A to C. Okay, so maybe the yeses and nos or something to some question. I find the answers to these questions in the case of the sample H, which I represent by the morphism H. And now I'm looking to carry on. You know, how do I go from my sample to the whole population? How do I find that G that will complete the triangle? So that seems to be an extension. So next slide, Nathan. Abduction I want to propose as a lift. And it sits pretty nicely, I think, when you've got some kind of epimorphism coming down from B to C. We've got some facts we can see in the world, this map from A to C, and we're looking to lift. I mean, one pretty explicit case would be if we're presented with a shadow. We've got a shadow on the ground, and we're wondering what on earth causes that shadow. And here, very literally, we think in terms of a lift. We have some candidates that might be causing this strange shape of a shadow here on the ground here. And if I could only lift my eyes, if you like, I could see what it was that was causing this shadow. And then you can see different kinds of observation in these terms. Sort of projections down from something, from some larger space, maybe. You know, the problems in computer vision. On my 2D screen, I'm seeing a little bit of something that looks like a head, and then I get a brown patch, and then I get something that looks like a tail. You know, you're naturally inclined, as the Gestalt psychologist showed us, to see that thing as an animal behind the tree. And again, this is a sort of lift up to the 3D space that is generating the 2D image. But plenty of other examples. You know, I may be given through H, I may be given a sentence, some kind of string, and I'm wondering, you know, what is the tree? How could I pass this thing in such a way that you know, I can come to understand what the sentence is, how it's been constructed. You know, and there may be many ways, many kinds of ambiguities that you know, you play on, particularly in certain kind of joke, where you lead the person to think that the tree that's being passed, the grammatical tree, is of a certain kind, and then, you know, it doesn't make sense, and you have to flip over. Okay, so you're looking for that lift F, and you know, you may be misled into lifting the wrong way, and then it doesn't make sense, and you have to find a new one. So next slide, Nathan. Yeah, so if you look at the bottom there, you'll see some notes. I'm sure you'll find access to these notes. You can email me if you want to see them. They're quite extended. But one way to think is in terms of these triangle completions going on in different categories. Because if I'm just working in, say, sets and functions, then and say in the extension case, the induction case, of course there are many ways that I could complete the triangle there with an extension. It looks like, so I mean, a classic case of extension in computer science is one where they use the nearest neighbor algorithm. So I've got my sample. Now, how am I going to go from the whole space to the labeling from the sample? Well, what do? I form a retraction. I come back from the full space back to the sample space by choosing the nearest neighbor. Okay, so when I'm wondering how to label a point, I find that the nearest neighbor that I do know the value for, and I use that. Okay, so there it looks like we've shifted away from the category of sets. We've gone to the category of metric spaces in some sense. So then you might wonder, so it looks like it seems to work best when this idea of mind, this association, when you have something more function-like going on in your category. Because if you play it out in the category of sets and relations, so there you're going to get, for sure, you're automatically going to get some natural extensions and lifts, like because rel has right Caen extension and right Caen lift is already there for free. But when you play it out there, it's not quite so clear because of this duality going on clearly in rel, that it feels like you need the direction of a functional kind of category to make it feel more like it's sort of induction and abduction. So you could work in the category of categories or some kind of enriched categories. And there is, it turns out, a whole lot of work that's already been done in the machine learning community of people trying to understand particularly inductive machine learning algorithms in terms of Caen extensions. Yeah, so for example, there's one method that's looking to form, so if you know anything about support vector machines, they're trying to find certain kinds of um, hyperplanes that divide a space in such a way that it suits the classification of the points you already know, and you're trying to draw a hyperplane through some space to separate away the pluses from the minuses. And you can see the choice of this hyperplane in terms of the maximum margin you can create in terms of this hyperplane to the points on either side. And you can understand this in terms of Carn extensions, right and left Carn extensions, in a very interesting way. But refer off to that article mentioned there if you want to see more examples of this. And then it sort of seems to be suggesting that, it looks on the face of it that induction is a kind of easier task, or conceptually easier task. It's just extension rather than abduction, which, I got to fish around for the right hypothesis. Sometimes it might be seen to be harder. And there's a kind of speculation there that you don't get Carn lifts for free in the category of categories, whereas you do get Carn extensions. Is there something in the asymmetry there that's sort of that kind of is associated with the difficulty of finding of abductive reasoning? Great. So over to Matt.
Yeah, mic check. Can you hear me? Cool. All right. Well, so in the first part of the talk, Nathan gave I think a rather compelling historical account of how Peirce anticipated a lot of category theoretic concepts that we do today through diagrammatic reasoning as part of his work on logic. And then David's continued this category theoretic account of diagrammatic reasoning by literally thinking about category theoretic diagrams as a way of parameterizing different modes of inference, which is something that Peirce had also thought about, but not in our modern terms. So the final ingredient, I think, to maybe to span Peirce's wide and comprehensive thought is his theory of semiotics, and that's actually been the most resistant to mathematical formalism. Yeah, next slide. So maybe I'll give you probably the most blistering overview of semiotics I could possibly give. So Peirce considered as logic to be a special case of semiotics. For him, signs were ternary relations between a sign or something which represents something, an object which is being represented, and an interpretant, which is a modification of the word interpreter, but it plays a more general and dynamic role in establishing a relationship between what is represented and the representing thing. And we've seen a lot of debates, actually, especially in category theory around semiotics, that the pattern 3 shows up a lot inside Peirce. You see monadic, dyadic, and triadic. But an important aspect of understanding Peirce's thinking is to think of them instead of, in his own terms, as firstness, secondness, and thirdness. So we can see that while we can freely talk about, more than ternary relations, the pattern 3 is actually much more significant to Peirce's underlying systematic thinking. So for firstness is a quality where experience is unmediated, and we'll give concrete examples in the next slide. But it's a quality of where something is unmediated, and then in secondness is more like a reaction. So now there is a sort of mediation, but now it's an immediate role. It has no explanatory power. It's instinctive. Thank you, Olivia. I'll try and speed through. And then thirdness is a mediation of that. So we'll actually, if you can go to the grid, we can probably get through a better. So on the top header, you have experiential, developing, generality, and logical. But for Peirce, that would be sign, object, and interpretant. And then the bottom and then the left column, you have these categories that I just enumerated. So we can see that for Peirce, concept formation for him can proceed progressively as we develop a finer understanding of the article of experience that we're dealing with. So in something which is experiential aspect of firstness is that you're feeling some sort of rain, you're feeling rain, but the rain that you're feeling is not really, it's very vague. It's just rainness. And then you start to think about the wetness, the coldness that you're feeling. And then it's establishing a reaction or a relationship between that, what is being felt and who is doing the feeling, even though that's very vague right now. It's just the skin. The skin just tells you what you're feeling. And then in thirdness, do you think, well, I gotta put on a raincoat. So like there's a habituated action that takes as given this this reaction and this primary feeling, and it mediates it, but it does so at a pre-lingual level. In the second column, you're working at the level of the object now. So for example, like a desktop icon or a picture of a raindrop would be an icon for rain. This is what Peirce would call an icon, and the desktop icon is very much the same. It does indicate a desktop or a computer, but it does so by its own likeness. So there's not really any sort of new information being. It's just its own likeness kind of making that relationship to you. Then rain being an indication of coldness or pneumonia or something, like it indicating something else. Or where there's smoke, there's fire is another example of indexicality. That's secondness. That's that reaction. It's indicating the actuality of something else. And then in thirdness, rain is now becoming like a symbol. It represents harvest. It represents fertility. It represents we gotta go inside. You might see a campfire on a park trail, and you say, okay, well, this is a safe where this is an area where it's okay to like, build a fire or something. And then the third column is that there's a logical. The firstness, secondness, and thirdness categories now take a higher form logically. So there's the term rain. Rain wants to be combined with other things. What do you mean rain? What do you mean weather? It's what is red? There's a blank there. It wants to combine with other stuff. There's valence, but it currently has no sort of relation to anything else. Then you say it's raining now, and now you have a predication. Like now you're saying a proposition. Now you're saying, oh, okay, there's a truth value. What does it mean? And then in the thirdness, now you have an argument. Now you're mediating, you're establishing a relationship between rain as something that you invoked, and then a sort of a proposition. So okay, so given that it is actually now raining, then something else is going to happen. So there is hypothesis being stated. So sorry, I'm trying to give a very blistering overview of this comprehensive topic, but it goes somewhere. Can you please take me to the next slide? So Gauguin, who is a influential computer scientist who passed away, I think, in the early 2000s, thought a lot about semiotics from the perspective of user interface design. His thinking was that we should think about everything as an interface, and that we should think about user interface in a principled way. And then not a lot of people have thought about that continuing him, although there are other people who continue Gauguin's work. And he leaves us with this great quote, which I think establishes that he understood Peirce's philosophy quite well, that it's a relational theory of meaning. We shouldn't ask what does the thing mean, like the object that we're studying programmatically. We should ask, what is its effect on the way that we think about things? What role does it play inside this grander system? And what Gauguin alluded to in his paper that's linked to, that's quoted here, is that Peirce's icons, indices, and symbols are important qualities for understanding how things should combine or blend together. But he never finished it. So if you can take it to the next slide, please. So yeah, his institution theory and and then there's another person named Leandro who's also doing this work. And maybe one more thing is that the Zalmea group in Colombia are also thinking about this too. So thank you.
Thank you very much, Nathan, David, and Matt. That was a wonderful talk. Let's thank our speakers, please. Are there any questions in the room or online? John? I'll bring you in. Here. Yes.
Yeah, I have a question that may be mainly for David. So you gave this great explanation of deduction, induction, and abduction in terms of filling in the third side of a commutative of a triangle. And you said that induction could be matched with the idea of Kahn extension in that setup, but there are right and left Kahn extensions, and I wonder if you have like some theory of like how to think of two flavors of induction. One is more lefty and one is more righty.
Yeah, good question. Thanks, John. Yeah, kind of. I mean, there's some people who thought a little bit more about this as well. Matteo Capucci, who's with some of his what's it called, quantificational propositional logic? No, yeah, QPL. So that's kind of intriguing to see it in an enriched setting, so that you're optimal, you're finding a sort of maximum or a minimum in some sense. That seems to come out very naturally. Yeah, but in situations where you had both, why would you want one rather than the other? That's interesting. I'm not sure I thought that through very much. I mean, there's something odd though, isn't there? Why in the rel case do you get the right? Why does the right Kahn extension exist and not the left? There's sort of interesting asymmetries that need to be explored a little bit further here, but I'll certainly want to pursue. So thanks.
Okay, thanks.
Well, I just wanted to say a comment. I think the left and right Kahn extensions are, because from the universal property, there'll be like the unique things you get from deduction. And there's two ways you can uniquely get induction from deduction. And those are the left and right. Just
Yeah. I suppose the question is, in a certain situation, would you rather have one rather than the other? Is there a sort of more natural one? But I mean, maybe it depends on context. As I say, it's used in this one case I mentioned. They're looking to find the place where the Kahn extensions are furthest apart. It's quite interesting.
Any more? Oh, one more.
Yeah, this is from Matt. This might be a naive question, but in that table that you had, where you had like sort of 3 layers on the first column, that to me, because I'm from the world of causality, that looks a lot like what Pell calls his ladder of causation. So you have this notion of observation, association, and intervention. Has there been any thought in the sort of work that you're doing in like regards to causality? Because that seems quite interesting to me.
Yeah, I'll leave this question also to Nathan and David, but I haven't heard of that connection before, so that's interesting to me. Nathan, I think you've thought more about this than I have.
Yeah, but I haven't heard that connection either. So it sounds compelling though. So I'll have to look into it for sure.
Thank you.
All right, I think that those are all the questions we've had. Oh, sorry, we still have Jules online. Jules, can you unmute yourself and speak?
Yeah.
Great, thank you.
Sorry, this is only tangentially related, but I thought I'd get you while I have you. I was just wondering if, as someone who does philosophy as a hobby but doesn't always know these things, it seems like a lot of like the structuralism is very similar to like things that people like Carnap and all the people who kind of developed model theory, like Tarski and whatnot, were interested in, about characterizing things. You know, things are characterizing things up to all their properties, right? I was just wondering, is there literature on this? Is this like a well-known kind of parallel, since both people were kind of working on these themes?
I think David can address this directly because he was working on, but there's a debate in philosophy of science about structural realism, and I think a lot of these issues come up. And David, I think, oversaw a PhD student working on this even. So
Yeah, I did a PhD on making Peirce relevant to modern philosophy of science, and thought, yeah, the resources of the Peirce actually makes sense where a lot of the complications, the confusions of modern philosophy of science can be understood through Peircean terms. If you buy into the full package of Peirce, that was the claim. Yeah, so plenty of interesting ideas there, I think.